All right, so this last section to today's class, in edition 2 of the book, it's called chapter 3, Basic Statistical Methods. I'm pretty sure the chapter is called the same thing in all of the editions, but it might be a different number chapter. So basics of statistical methods. And I just want to highlight some of the statistics that may appear on your comps or your NCE. Some of the statistics are done in this class. Most of them are done in the assessment class. But a lot of the terminology is also done in this class in other lectures. Like we talk about population and sample, and we're going to talk about the model and reliability and validity of your measurements. And so those kind of terms can also appear on the exam, but I think they included all of the statistics that you need, at least from the research class, in this chapter, in this one chapter. So you should use this chapter as a study guide for that, and also whatever's being taught as far as statistics and terms in the assessment class. So on the larger exams, the comps and NCE, research and assessment are together in that category. So when you're kind of studying for that category, it's those two classes. I also uploaded my personal notes that I use to study from. So you can use those notes. It talks about all of the statistical concepts, all of the terminology that I thought was going to be on those exams, and I didn't find anything that surprised me. So I think those notes are pretty up to date still. So you could use those notes that I uploaded as a study guide as well. So let's talk about some of these. I'm going to give you some basically helpful hints on how I remembered these concepts. Because at first they seem like very complicated stats concepts, but they're really not. Okay, so the first thing, and I've seen this and heard about it on every single exam so far. And the first thing is basically it's under the category of scales, measurement scales. And there's a table for this in the chapter, but I just kind of want to give you an idea of what each one is. And so there are 4 scales. There's nominal, ordinal, interval, and ratio. We'll go over each one. So nominal actually comes from like Greek or Latin, I forget which one, but noma means to name. Okay, so that's how I remember it. And it even nominal even sounds kind of like naming. So basically, it represents a number, represents a category. And so if you ever use a statistics program like SPSS, it really uses this concept quite a bit. So, for instance, when you're handing out a survey, And it might have basically ethnicity as a category. You might want to know about ethnicity. So you might have African American, Asian, Caucasian. You might have a long list of ethnic categories, even other, it's not mentioned. But you would have a number for each category. African American may be number one. The Asian might be number two. Caucasian might be number three. That's not ranking it in any way. The number simply represents a category. You could put it in a different order. It doesn't matter. So the numbers no longer represent, something that could be added or subtracted. One is a certain category. Two is a certain category. It's almost like on a baseball team or a football team when people have numbers on their jersey. Player number one doesn't mean they're the best player, just means number one equals Grafton. Number two equals somebody else, So rather than just a name, they have a number on their uniform. And that simply represents a player, okay? Doesn't represent how good they are. So that's the first thing. And basically, in a statistics program, when you're typing in the data, for every African American, I might type number one 100 times. For every Asian American, I might type number two 150 times. For every white Caucasian, I might type number 350 times. Okay, it tallies up how many times that number appears. So that number is no longer a number. It's like the number on a jersey. So, okay. Now, I did misspeak because it's a nominal scale isn't actually even called a number. It's a numeral. Okay. So if you're going to get like really specific, there are numerals and there are numbers. So numbers you can use in a mathematical calculation, but a numeral is representative of a category. So just to be specific. All right, ordinal. This is a pretty easy one to remember because the word ordinal comes from order. So it does represent a position for a variable. So it may not have the same value as a number. It might not be able to be added or subtracted, but it may represent ranking. So, for instance, military rank would be an ordinal scale. So you might have lieutenant, captain, major, colonel, general. So that would be an ordinal scale, because rank means something. They're not all equal. The order means something. It prioritizes in some way. So that's also a numeral. Okay, so the next two are numbers. So interval is a number. It represents equal units. So let's see. So the difference, this is often a question on the exam. They might have an example of one of these, nominal, ordinal, interval, or ratio. Okay. If it's either interval or ratio, the way to tell the difference is ratio can have a true zero, but interval can't. So if it involves a zero, it's a ratio. If it doesn't involve a true zero, it's an interval. So that's an easy way to give it away. If it involves ranking or a category, it's nominal or ordinal. Okay, so there's no true zero on the scale, on an interval scale. So technically, there's no zero on an IQ scale. Technically, you can't really just have a zero. And a ratio scale represents equal units and also has a true zero. So weight is an example of a ratio scale. Another example is the Kelvin temperature scale. It has zero. So any operation, any calculation can be done with a ratio scale. All right, there's a little table in the book that lists each one of those 4 scales. So that is usually a question. Okay, we have common statistical definitions, and this is more about like terminology, but there is a mathematical component to each one of these terms. So the first thing I want to do is talk about the 3 types of averages. So the average, this a lot of times when people or organizations present statistics, or maybe they're selling something, trying to convince you of something on the internet, maybe it's something about politics, they don't use the appropriate average. So there's mean, mode, and median, and they might share the median with you, but in reality, they should have used a mean. So people can fool you with statistics, and the computation may be correct, but it's not the right statistical method to use to convey the data. So let's talk about those 3. The first one that you probably already know when you say, oh, well, that's average, okay? Most people are referring to the mean. And the way you figure out a mean is you take all the scores, add them up, and you divide by the number of scores. So let's say 10 people take a test, you type in all 10 scores and you divide by 10. That's the mean average. So rather than just saying average, people should say mean average or mode average or median average, so you know which average they're actually sharing with you. Okay, median, the way I remember that is, I think about a highway, and the median strip is that strip of grass in the middle of the 2 lanes of a highway. So median refers to the middle point. So that's how I remember it. You can come up with your own memory device. But 50% of the scores fall above it, 50% of the scores fall below it. It doesn't mean the exact middle of possible scores. It's the exact middle of the result scores. So people might look at the median score in my classes, and it's like 99%, but that's out of 100. That's because I use mastery learning. You can keep doing it over and over again until you get it right. But if you're in like another department, like the education department, they might have a bell curve, and the median might be, 80%, 75%, something like that. All right, the last one is the mode, and that's simply the most frequent score, which score occurs the most. So you can see how people can manipulate data just by which type of average they choose to present. All right, so that's how you figure out each one of these. So they might give you a bunch of scores, and they might say, which is the mean? What's the mean? Or what's the mode? Or what's the median? And they'll have A, B, C, D. E is none of the above. Or A, B, C is, so A's mode, B's median, C is mean, D is none of the above. So that's what it'll look like on the test. Okay. A frequency is very close to mode. So we're not talking about averages anymore. These are different terms. A frequency is very similar to mode, but you don't have to, it refers to the number times a score is found in a distribution. So what's the frequency of a B? So if a B is, 80%, how many B's did students get in a class? Distribution refers to how scores range through, I don't even want to use the word range. In the book, they use the word distribute to define itself. I don't like using a word to define itself. So how scores are spread across a data set. That's usually not on the exam, but range often is. So the distance between the highest and lowest scores in a distribution. So scores might be from 10 to 100. So if they ask for the range, you subtract the lowest score from the highest score. So you have a range of 90. So if scores in a class ranged from 10 to 100, it's 100 minus 10, and that's 90. So that's the range. And scales of measurement refer to the type of scales using, and that's nominal, ordinal, interval, or ratio. All right. So now let's look at this. And let me share my screen. We're going to look at standard deviation. Here we go. Let's see. Okay. Okay. So this red, yellow, and green is standard deviation. And this little symbol here, that's means deviation, basically. That's one. So here we have this right here is the average in the middle. And then this is one standard deviation, two standard deviations, three standard deviations, and the rest. Now, this is a negative standard deviation to the left, 2 negative standard deviations, 3 negative standard deviations. So there's a number of different ways to look at this. So on an IQ test, 100 would be in the very middle. So one standard deviation to the right, a positive standard deviation, is usually 130, 129, something like that on an IQ test. So when we think about that, on an IQ test, 130 is considered gifted. I'm just coming up with an example for you, so you can kind of have an example in your mind. 150, the next standard deviation is considered genius, basically. Usually 85 is considered having some type of cognitive struggle. However, sometimes school districts go with something below 80, depending on how they want to use their funding. And then 2 standard deviations is more severely impacted. And then, so here's the thing. If you go 1 standard deviation to the right or 1 standard deviation to the left on an IQ test, most people fall within 1 standard deviation to the left or right on an IQ test. So let's use these percentages. So you've got 68.2% of all people, 68.2, fall within 1 standard deviation of the norm of 100%. So if you look, this is also called a bell curve. It kind of looks like a bell that you would ring. So these numbers are difficult to remember because they are point something. And it's also difficult to figure out in your head or on a little piece of paper during a test. So you can round these off. Okay, so you could say 34% is 1 standard deviation from the norm in either direction. You could say that 13.6 or 14%, if you round it off, that's the second standard deviation in either direction. So just remember 14. So 34, 14, and 2. That's how I memorized it. So no matter what, if I gave you the example of an IQ test, all right, but they might give you an example of a test where the norm was not 100. It could be 200. It could be 150. It could be any number. But as long as you remember 34, 13, and 2, you can figure out any standard deviation, no matter what number they give you as a norm. And they will give you the norm in the middle to figure it out. So the other numbers down here, you don't even have to remember. All they do is add up 34 and 34, which is 68%. So that's 1 standard deviation on either side. And then they add up the total here. So 2 standard deviations would be 34 and 14 on either side. And that's 95% of the population. That's almost everybody is within 2 standard deviations of the norm. And this last one's only 2%. And that brings you all the way up to almost 100%, 99.7. So almost everybody falls within 3 standard deviations, plus or minus. So when you hear this terminology, that's kind of how you figure it out. But all you have to remember is 34, 14, and 2. The trick will come in. Do they just want 1 standard deviation on one side, or do they want the negative and the positive? So you either have to add them together to get 68, or you do one side. So you might say positive standard deviation. They might say a negative standard deviation. They're the same. You just put a positive or negative in front of it. But they might say plus or minus, positive and negative. Then you have to add them together. All right. So I know that's a little complicated, but that's about as simple as I can make it for you to memorize. So questions about standard deviation. All right, let's look at t-scores and z-scores. All right, so I can get into how to use t-scores and z-scores in a study and why, but they're never going to ask you that. What they're going to ask you is to convert a z-score to a t-score, or to convert one way or the other. Convert a z to a t, or convert a t to a z-score. So this is how you do it. So the way I remember it in my own mind is t equals times 10. That's how I remember it. T is 10. So a t-score equals 10 times the z-score. They'll give you the z-score plus 50. If they give you the t-score, a z-score, you don't times it by 10. And that's t minus 50 divided by 10. So that's the only thing you have to remember if they ask you to convert one to the other. I just remember t means times 10. Z means divided by 10. That's how I remember it. And then you tag on the 50. All right. So let's see. Let's see what else. Oh, okay. So in the book, it gives you examples of all kinds of tables and graphs. So it gives you like a bar graph. It gives you positive and negative correlations. And so the way I remember those two types would be positive. I think things are getting better. Things are moving up. So positive is when the dots on a graph start low on the left and move up and get higher on the right. So I just think of that as like moving on up. Things are getting brighter and more positive. All right. A negative correlation goes the opposite way. Things are going down. They start high on the left and they end up low on the right. So that's how I remember that. A bar graph, you all know what a bar bar graph looks like. I have most of these as examples in the dissertation that I uploaded. So I have tables, bar charts, pie graphs, I have correlational charts. So you can see examples of all of these if you just go to the pictures in my dissertation. Let's see. Okay, so inferential statistics. They have a table and they have ANOVAs, factorial ANOVAs. They have repeated measures of ANOVA, multivariate analysis, that's a MANOVA. They have an ANCOVA, analysis of covariance. They have multiple regressions, chi-squared, structural equation modeling. And they tell you what each one is. And this is, totally up to you. They'll give you an example and you get to say which one you should use. And honestly, it's a lot to memorize. So if I was going to miss 1 point on the NCE or the comps, this would be it. Because even though I've actually used these, I don't know if I could get it right. Other people might be better at stats than me, but each one is described in 1 page in your book if you want to memorize it. All right. Yeah, that's it for that chapter. So that's the quick statistical updates on how to take this portion of the exams. We're not going to use any of these for your paper or study, but gives you an idea of what each of those terms is. We're still going to have a class on reliability, validity, measurements, things like that. So you'll need to know those terms too. Don't wait until the last minute to memorize this stuff. Even though I'm not giving you an exam in this class, now's the time to study the notes I uploaded. All right.